Good morning. Today we discuss integration by trigonometric substitution. Okay. If the integrand is one of the expression like 1 by 1 a square minus x square root 1 by x square plus a square 1 by root over of x square plus a square 1 by root over of x square minus a square and 1 by x root over x square minus a square, then with the help of trigonometric identities like a sin square theta plus cos square theta is equal to 1, from which we have sin square theta is equal to 1 minus cos square theta. Also we have cos square theta is equal to 1 minus sin square theta. And another identity is sec square theta minus tan square theta is equal to 1. Cosec square theta minus cos square theta is equal to 1. Then with the help of these trigonometric identities, the radical sign, that means root over, the radical sign in such expression can be eliminated. The radical sign in such expression can be eliminated. Okay, the radical sign in such expression can be eliminated. Okay, thus the integrand becomes simpler and can be integrated easily. Okay, the integration of this integrand, now we integrate the above integrand. So we write here the integration of the above integrand are given below. Okay, the integration of the above integrand, that means 1 by x square minus 1 by a square minus x square root 1 by x square plus a square root 1 by x root over of x square plus a square 1 by root over of x square minus a square 1 by root of x root over of x square minus a square. Okay, this integrand, now we integrate this integrand. First we integrate 1 by integral dx by a square minus x square root. Okay, now we integrate the integrand 1 by a square minus x square root. Remember, where the form is a square minus x square, then you put in place of x as sin theta or cos theta. If the integrand is in the form x square minus a square, then you put either sec theta or cosec theta. If it is in the form of x square plus a square, then you put in the place of x as a tan theta or cot theta. Okay, here the form is a square minus x square root. So we put here, put x is equal to a sin theta. A sin theta. That implies d by dx, d by d theta, dx by d theta is equal to a d by d theta of sin theta. That means you differentiate both sides. So we have dx by d theta is equal to a cos theta. That implies dx is equal to a cos theta d theta. And also we write here sin theta is equal to x by a. That implies theta is equal to sin inverse x by a. So the integral becomes a cos theta d theta divided by a square minus a square sin square theta root. That equal to integral a cos theta d theta, that taking common a square 1 minus sin square theta root. Okay, that equal to integral a cos theta d theta, a square cos square theta, 1 minus sin square theta as a cos square theta. So a square cos theta root. So we get that equal to integral a cos theta d theta divided by a cos theta. Now cancel a cos theta, we get only d theta, that equal to theta plus c, that equal to sin inverse x by a plus c. So integration integral dx by a square minus x square root is equal to sin inverse x by a plus c. Remember, this is one of the formula. Next, we integrate dx by x square plus a square. Dx by x square plus a square. Okay. Dx by number 2, integral dx by x square plus a square. Put x is equal to, in the form of x square plus a square form. If the integrand is in the form x square plus a square, then we put in place of x as either a tan theta or a cot theta. Here we put x is equal to a tan theta. So tan theta is equal to x by a. That implies theta is equal to tan inverse x by a. Now differentiate both sides. D by dx by d theta is equal to d by d theta of a tan theta. That implies dx by d theta, that equal to a d by d theta of tan theta. That means sec square theta. Dx by d theta is equal to a sec square theta. That implies dx is equal to a sec square theta d theta. Okay. So the integrand becomes integral a sec square theta d theta divided by a square tan square theta plus a square. Okay, that equal to integral a sec square theta d theta. Taking a square common, we get tan square theta plus 1. That means a square that equal to integral a sec square theta d theta divided by a square sec square theta. You know 1 plus tan square theta is equal to sec square theta. Tan square theta plus 1 is equal to sec square theta. You know sec square theta minus tan square theta is equal to 1. So cancel sec square theta, that means d theta by a. So taking 1 by a out of the integral sign, d theta that equal to 1 by a theta plus c that equal to 1 by a tan inverse x by a plus c. Tan inverse x by a plus c. So dx by x square plus a square is equal to 1 by a tan inverse x by a plus c. Okay. Next we integrate dx by x square plus a square root. Dx by x square plus a square root. Okay. Number 3, integral dx by x square plus a square root. Here we put x is equal to a tan theta and tan theta is equal to x by a, that theta is equal to tan inverse x by a. Here we differentiate both sides with respect to theta. Dx by d theta that equal to a d by d theta upon tan theta. Since a is a constant, taking out of the derivative, dx by d theta a sec square theta. That implies dx is equal to a sec square theta d theta. Okay, so the integrand becomes a sec square theta d theta divided by a square tan square theta plus a square root, that equal to integral a sec square theta d theta, that a square whole into tan square theta plus 1 whole root, that equal to integral a sec square theta d theta a square sec square theta root. Okay, so we write that equal to integral a sec square theta d theta divided by a sec theta, that integral sec theta d theta. Cancelling the numerator a and denominator a. Sec square theta with sec theta, we get only sec theta. Okay, you know the integral of sec theta is ln sec theta plus tan theta mod plus c1. That in place of sec theta we write ln tan square theta plus 1 root plus tan theta mod plus c1. In place of tan theta we put ln x square by a square plus 1 root over plus x by a plus c1. You know tan theta is equal to x by a. So here ln x square plus a square, x square plus a square divided by a square whole root plus x by a mod plus c1, that equal to ln x square plus a square root divided by a plus x by a mod plus c1. Okay, that equal to ln x square plus a square root plus x whole divided by a mod plus c1. Okay, next we write ln x plus ln x square plus a square root plus x mod minus ln a mod plus c1. That means ln x plus x square plus a square root mod plus c1 minus ln a, that equal to ln x plus x square plus a square root mod plus c, where c is equal to c1 minus ln. Okay, so the integral of dx by, so integral of dx by x square plus a square root is equal to ln x plus x square plus a square root mod plus c. Okay, next we differentiate dx, we integrate 1 by x square minus a square. Okay, for integral dx by x square minus a square root, here x square minus a square, so we put here either in place of x either a sec theta or a cosec theta. Put x is equal to a sec theta and sec theta is equal to x by, that implies theta is equal to sec inverse x by a. Now we differentiate both sides with respect to theta. Dx by d theta is equal to d by d theta of a sec theta. That implies dx by d theta is equal to a d by d theta of sec theta. That implies dx by d theta is equal to a sec theta into tan theta. That implies dx is equal to a sec theta into tan theta d theta. So the integral becomes a sec theta into tan theta d theta divided by a square sec square theta minus a square root. In place of x we put a sec theta. So here x square means a square sec square theta. That equal to integral a sec theta into tan theta d theta divided by a square whole into sec square theta minus 1 root. Okay. Now we write a that equal to integral a sec theta into tan theta d theta divided by a square tan square theta root. Integral a sec theta into tan theta d theta divided by a tan theta. A tan theta. Now we cancel the common factor from numerator and denominator. We a tan theta, we get only sec theta. Integral of sec theta. You know, ln sec theta plus tan theta mod plus c1. In place of tan theta, we put sec square theta minus 1 root ln sec theta plus root over of sec square theta minus 1 plus c1. That equal to ln sec theta plus ln, in place of sec theta we put x by a, so here we write x by a plus x square by a square minus 1 plus c1 root over of x square by a square minus 1 plus c1. So here ln x by a plus x square minus a square divided by a square whole root plus c1, that equal to ln x by a plus x square minus a square root by a plus c1. Okay, that equal to ln x plus x square minus a square root whole divided by a plus c1, that equal to ln x plus x square minus a square root mod minus ln a plus c1, that equal to ln x plus x square minus a square root mod plus c1 minus ln a, that equal to ln x plus x square minus a square mod plus c, where c is equal to c1 minus ln a, okay. So integral of dx by x square minus a square root, that equal to ln x plus x square minus a square root mod plus c, okay. Next, last formula, get dx by x root over x square minus a square, 5 integral dx by x root over x square minus a square. Here also we put x is equal to a sec theta, and a sec theta is equal to x by a, that implies theta is equal to sec inverse x by a. Now we differentiate both sides. Dx by d theta is equal to d by d theta of a sec theta. That implies dx by d theta is equal to a d by d theta of sec theta. That implies dx by d theta is equal to a sec theta into tan theta. Okay, a sec theta into tan theta. That implies dx is equal to a sec theta into tan theta d theta. Sec theta, tan theta, d theta. So the integral becomes integral a sec theta into tan theta d theta divided by a sec theta root over of a square sec square theta minus a square sec square theta minus a square. Okay, now integral a sec theta into tan theta d theta divided by a sec theta root over of is taking a square as common, so we get a square over sec square theta minus 1. Okay, now cancelling a sec theta from numerator and denominator, we get a tan, that equal to integral tan theta d theta divided by a square tan square theta root, you know, sec square theta minus 1 is equal to tan square theta, that equal to integral tan theta d theta divided by a tan theta. So we get integral d theta by a, cancelling tan theta from numerator and denominator, 1 by a integral d theta, that equal to 1 by a theta plus c, that equal to 1 by a sec inverse x by a plus c. So integral dx by x root over x square minus a square is equal to 1 by a sec inverse x by a plus c. Okay, so finally we write standard formula. Okay, standard formula. Remember, first integral dx by a square minus x square root, that equal to sine inverse x by a plus c. Number 2, integral dx by x square plus a square, that equal to 1 by a tan inverse x by a plus c. Number 3, dx by x square plus a square root, that equal to ln x plus x square plus a square root mod plus c. 4, integral dx by x square minus a square root, that equal to ln x plus x square minus a square root mod plus c. Number 5, dx by x root over x square minus a square, that equal to 1 by a sec inverse x by a plus c. Okay, these are the standard formula of this chapter, so remember it. Okay, thank you.